Okay. Welcome to our webinar again for all those people who joined after my first introduction. My name is Sebastian Fischer. I'm product manager for the dataFEED SDKs, and I'd like to welcome you to this webinar. With me here in this webinar is Thomas Merck. He's senior software developer for our dataFEED SDKs and therefore our C++ toolkit, and he will do the presentation afterwards for the client development. But first of all, let's have a look. What are we? What can we do to support you? So first of all, I will give a short introduction about our company, about Softing. Then we will have a look on all our dataFEED SDKs, and afterwards I hand over to Thomas Merck, who will then do the client development. So company, Softing. Softing AG is a small company. We are a management holding according to the German Mittelstand, and our headquarters is in Haar near Munich. We have a revenue around 80 million euros per year and around 415 employees. We are present all over the world with local staff also in Japan, USA, India, and China. Softing has several business units. One business unit is automotive. Automotive handles or has products for onboard diagnosis for cars and several more topics, which are all for the automotive sector. Then we have IT networks, which produce or have products for measuring equipment for IT systems. And then there's Softing Industrial and their Softing Industrial Data Intelligence. That are we have products for industrial production and for industrial integration, and especially here for OPC UA. So let's have a short look on our dataFEED SDKs. We have SDKs for OPC and OPC UA and for Visual C++ and .NET. Our SDKs are all based on the stack of the OPC Foundation, and the benefit for you there is that we put a client or a server API on top of this stack. So we simplify all the functionality that comes with the stack and bring you a better better handling of everything that you need for OPC UA. Additionally, we provide examples, tutorials, and easy to use first step guides so that you have a good start with OPC UA and with our toolkits. If we have a look on our C++ toolkit, there we have a client and server API for you. And if you are developing on Windows machines, we provide solution files for Microsoft Visual Studio. If you have a development environment as Linux, we can provide you something there as well. Our development target operating system for your development are Microsoft Windows, Linux, and also VxWorks. If we have a look on our .NET portfolio, there we have the .NET toolkit for client and server, and we have the .NET standard toolkit with the latest and the freshest kit in our portfolio. There we provide also solution files for Microsoft Visual Studio, and the target operating systems are for the .NET toolkit, the only Microsoft Windows, and for .NET Standard, you can also deploy your application to Linux and Android. For .NET Standard, we currently have only a client API for only a client API. The server is currently in development and will be released probably this quarter. Then we have also our classic toolkit. We have there a classics client and server, also with the simplified API for data access and alarm events. This all runs only on Windows, as a classic OPC only is based on Windows systems. There we have an implementation for C++, C#, and Visual Basic.NET. Additionally, we can help you in testing your application by providing a free dataFEED OPC UA client. You can download it simply from our website and can use it to browse your server and test your server as long as you would like to do. Also, if you are developing a client application and you are looking for a demo server, we can provide you something there as well. We have a demo server application with a predefined address space that you can use to test your client application and browse this server. So how is the sales model of our dataFEED SDKs? For the classic toolkit, we have a license model. So you buy a license from us, and additionally you can buy a maintenance contract that you get updates, future updates for free. But you have to purchase the maintenance contract additionally. If you are now looking to the OPC UA toolkits, they are only sold based on a maintenance contract. That means that the license is sold for €1, and the maintenance contract has to be also purchased, which will then run for 3 years, so that you will get updates for 3 years. Also, you will get technical support from our dedicated support team, and if needed, we can provide you also with consultancy that you have an easy start for your application, and we can help you there. All our toolkits have a free demo version which runs 90 minutes. After 90 minutes, you only have to restart the application and it will run again for 90 minutes. So there's no problem in testing our application. Simply go to our website, log in or register first if you are not registered, download the toolkit, and you are ready to go. Then you can test the application as long as you would like to do. So you're not buying something that you don't know, and if you are satisfied, then contact us and we can provide you everything else regarding our purchasing our toolkit. So then, just to give you some reasons why you should choose our dataFEED SDKs. First of all, with our easy API, you have a fast time to market because you don't have to know all the insights of OPC UA. You can simply download our toolkit, read our documentation, and with the help of our examples and tutorials, you are ready to start in about 1 to 2 weeks if you are saying or thinking about a client development. Also, you are independent of OPC foundation stack changes. So if something changes in the stack, there's no need that our client API is changing. We are handling all this, and you can still use your application and include the latest version from us without any changes. Also, we have, as I previously mentioned, the documentation, tutorials, and examples. We use the dataFEED SDKs also in our own products. Maybe you have seen our dataFEED suite or our gateway solutions. They are all based on our C++ toolkit, and therefore we know what we are selling. With a maintenance contract, you have the free upgrade for 3 years, so you will always be up to date. And this also includes feature updates and not only bug fixes. So if we are talking about the new specification 1.04, if you have a maintenance contract with us, then you are always able to get the new features and don't have to rebuy a new license. We guarantee you the full OPC compliance. We regularly test our toolkits against the OPC test or compliance test tool, and therefore we can guarantee the OPC compliance. You know, we have the demo version and we have the support by email and telephone. And if you would like, we can support you with training and do a special development support. So if there are any questions, please feel free to simply type them into the questions window. And I see there's one question.
Yeah. Is it necessary to procure a maintenance contract for licensing the software?
So if you would like to have a license from our software, you have to buy a maintenance contract. You cannot buy the software for €1. There's always the package with the license and the maintenance contract. So this comes in a bundle. If you decide not to stay with us after 3 years, you can discontinue the maintenance contract, but the license is still valid, and you can use your application as long as you would like. Also, the maintenance contract is for one developer seat, so you don't have to pay for every sold or shipped application you sell. You only pay for the developer seat.
Okay, there are 2 more questions. Okay. Somebody missed the first part.
Okay, if you missed the first part, we are currently we are recording this webinar, so it will be on our website afterwards, so you can see the first part. So I think then we have
any plans for iOS and Swift?
Currently, there are no plans for iOS and Swift, but we are supporting .NET Standard for the .NET Toolkit, and therefore it is possible also to use our toolkit with iOS and Swift, but you have to do the changes yourself. We currently do not provide any support for that. Okay, I think for now we have answered enough questions. All your questions, also those who we are not answered during this webinar, will be answered afterwards from me or from Thomas Merck. So please feel free also to write some questions during our presentation. So then I will hand over to Thomas, who will then do the presentation for the client development.
Yeah, hello, Turo. So I plan to show you simply the development. Okay. Okay. Yes. Forgot. There's another slide. So the C++ toolkit, or almost all toolkits, are implemented in that way that we use the stack which implements the encoding, the secure channel handling, and the transport. That's the gray box. And then the UA toolkit, both client and server side. And this toolkit implements loads of the business logic for service handling. Some pre-processing in server, business logic for sessions, subscriptions, monitored items, and so on. And as well, support for clients to connect to redundant servers. And obviously the API to simplify the usage of UA in general. Okay, that's all. Sorry. So now I shall show you simply Visual Studio on Windows to show you how easy a client can be developed. The complete client application is based on the very simple tutorial for client development that shows you how to load, unload the toolbox and so on. And after that, this was developed for such reasons like this webinar. Okay, some header files have to be included. Obviously, we are using the toolbox. Okay, it's still named toolbox, not toolkit namespace. In this sample, the server, the client knows the URL of the server. Typically, we simply use the local host on with a dedicated port where our test server is running. It provides some paths where the certificates are stored. Okay, we'll come to that later. So this sample will not use any security, but it is recommended to have a known certificate available Otherwise, some servers might refuse to connect. Okay, here are some function declarations, not yet of interest. This is the usage, what our sample will do. Okay, it will shut down, it will connect to a server or disconnect from that server. It will read a variable value or write a value to that variable, monitor a node, a variable node for data changes, and stop monitoring the variables. So that is most of the functionality necessary for easy OPC UA clients. And here we start with the main functions. First of all, we will adjust the certificate path. That's just something internal. I can show you. Oh God. I can show you what's done. If the paths are specified as relative, then we simply adapt the paths to the executable path. That's everything. And as we saw, the path is relative to the executable, and the executable path is stored in the solution directory and a subdirectory of the configuration, like here debug. Yeah. Then we have to load the toolbox. You always have to invoke that before any calls to the toolbox and unload the toolbox afterwards. And then in between, you can do anything with the toolkit provided. And in between, we run our client application. We have a singleton application implemented in our toolkit. This can be accessed with an instance method, and you get the singleton back. And first of all, we have to define our application description. That is, defined by the specification. What you have to define. First of all, we simply get a computer name. It's necessary for the certificates and for the application to have a unique instance name, and by providing the host name or the IP address, or don't care, we think that this can be done quite easily. Okay, we are developing a client. We have an application name, UA client, and we have an application URI, and here comes the host name again to have a unique URI. And we have a product URI, which simply specifies the product name. Okay, just a sample client. With that application description, we initialize our application singleton, and then we provide the instance certificates of that application to our application singleton by simply providing the application certificate file name and the private key file name and the private key password. Don't care about those verify results. Or let's say each and every API method has a result which is of type enum status code. On that verify macro, simply I can show you, simply verifies whether this status code was good provided by the toolkit. Otherwise, I simply implemented a printf to see if something failed. So in that case, if you specify a non-existing file or something, you will get a bad result, and you immediately know that you have configured something wrong. So after that, the application is completely configured. Now it has to be started. This will launch some threads in the toolkit for asynchronous processing. Yeah. Don't forget to do that. Some parts will work, most won't. After that, we are running the user interface of our client. And if we want to shut down, we simply stop the application and uninitialize the application, and then it's done. So far, quite easy. Our test or our sample client, our sample client uses a user interface simply as a command line application. That's easy, what we always do, since we always want to test our applications on various operating systems, and this is the command line is always available and everywhere. Yeah. Here I already implemented an additional feature. I did not even remember that was in that part. So we implement a forward class declaration of my session. So a client has a session, and the toolbox provides a client session. If a client wants to connect to a server, it has to establish a session to that server. And we simply derive from the toolkit provided session and override a method which is virtual on status change, which shows you if the client, if the server connection is broken, then you will get a notification that the connection is broken. And that's simply implemented here. If we get such a notification, then I simply print out that the status has changed to connected or disconnected. So quite easy. Okay, the user interface. In the user interface, we have a local variable of a session, and this session PTR is a smart pointer. And we always store those things as smart pointers, so that are reference counted, and if the last reference is gone, the object will be deleted. And in most things, we are providing such a static create method to provide us such a smart pointer. The same for the subscription, but this is not yet initialized, so it's still null. And we store that here in that user interface as a variable. So this session and this subscription will be available on all during all that function. And if we exit that run user interface, this is automatically destroyed. Okay, once the session is created, we we give that session to the application. And then we start our endless loop. We print our usage, and we start our endless loop. And the input processing is simply done via a string stream. Yeah. We have a call result variable here. So if you type an X or a Q, then the client will shut down and sets simply that end flag, and the endless loop will be broken. So the first functionality of interest will be how to connect to a server. That complete input stream things handling is almost out of interest, because that's only for this sample here. So the connect to server is implemented in a separate helper function, and I shall show you here. Again, I get the application singleton, a session which is an in-out can already have a URL or not. If it already has, if the different URL is provided, then the old session is disconnected, and the new session will be configured. Initially, the session will have an empty URL, so we will have to configure a new session. For configuring a new session, we'll connect to the server and get the information what security configurations and user authentication the server provides. this is done via that endpoints, get endpoints from server, which will provide us an endpoint description list. And out of that endpoint description list, we have to search the endpoint, the security mode, and everything we want to use. So we simply iterate over that endpoint descriptions and search for an endpoint that provides us a security none for that sample. If you want to use other security, it's up to you to search for another. Once we have found an endpoint description with that security, we have to search for the identity token. So each and every endpoint provides a list of user authentication possibilities. And we'd like to search for a user identity of anonymous. That's the quite easiest thing. No security and anonymous, so no authentication is necessary. But if we have found something, we simply use this found endpoint description and user token. Now we configure our session. We set the URL. We set the server certificate as exposed in the endpoint description. We set the security configuration to none. Yes, we want to connect with no security. And the security policy is also none. And we want to use an anonymous user, so we configure our session with the user identity token of that anonymous token. We also configure here an auto reconnect interval of that session. So if the connection is broken, the toolkit tries to re-establish the session every 10 seconds. We can show you that afterwards. And finally, once the session is configured, we connect the session, including all subscriptions, and because we provide here the true, and that connect has the interface bool deep. Deep means including all subscriptions. Okay, actually we do not have yet configured a subscription, but we will see that later. Okay, here we are at the connect. We get a result whether the connect has succeeded, and we get a printf. The disconnect of a session is quite easy because, okay, if we have a subscription, we disconnect the subscription again, as in that sample, or we specify that the session disconnects, and this will disconnect the session from the server. That's a direct toolkit functionality, so no extra function here implemented. The next thing for functionality would be the read of a value, of a variable value. As you know, the nodes, the variables are displayed in the address space as nodes of a specific node class and identified by a node ID. And this is the way how we simply, or more or less simply, try to parse our command line input to a node ID. We simply use the input as a string, and if no string is provided, then we use a default node ID that is the current time. That string can be parsed with a toolkit functionality to a toolkit node ID, and then we want to read that node with that node ID. So we have to provide more information for that read, and that read information is provided in the read value ID. The major thing is definitely the node ID, which node has to be read, but not only the attribute value can be read, all attributes can be read, like display name or anything else. And the specification provides that not only one variable can be read at a time. So everything is always a list of variables or a list of attributes of the same variable can be read with one single service call. So we provide a vector of read IDs, and we simply push back that here and provide that vector of read IDs to the session read functionality method. This is again the easy toolkit implementation of the read with the additional information, which timestamp has to be provided, the nodes and attributes to be read, an optional how it's named, not deadband, it's a max age value. So if a server has already a cached value, whether the server can provide you the cached value or has directly read from device, and the out parameter is the read results. And the complete service we invoke has a call result, a service result. Yeah, the read results typically have a status code inside and the value. And we provide something like a toString to show you what we got for that read result. And if the server provides you a good service call, then the number of read results have to be the same number as the nodes to be read. So the complete functionality regarding UA is done in that one method to read a variable value. And here, before we simply provide the configuration, what values have to be read. Yeah, the same or almost the same for the write functionality. If you want to write a variable, I can skip that almost. It's all things that are the same, except the value. Parsing the value is done in a utility method. I can show you just quite fast, where the value has to provide it first the data type, and then if the data type matches, we can parse that string to a used data type ID. And in case of a Boolean, we expect a true or a false. Or in the case of a double, we simply use the stream functionality to parse the stream into a double and an end. So but that's just for that sample. If you develop your own client, you will have your input values from a different way, obviously. As well, like the read, multiple values can be written in one service call. So we always have a write value vector, an array, and we get an array of results. We configure our write values. We want to write that node. We want to write the value attribute. We provide the value that have to be written and configure our array with that thing and invoke from the toolkit the write method. And if the data type does not match, we will get the bad result. Otherwise, the server shall accept the written value. And here is just a print of the result we got from the server. Okay. If you want to monitor for data changes, it's again for our tests or for our sample here, quite easy. We always want to monitor some node ID as above. And okay, and after that, we have implemented a separate functionality to create a monitored item that is doing the job. This function also has as input the current session, the current subscription, and the node ID. So first of all, we create a monitored item. Okay, with a sample monitored item. I really cannot remember what I did. Yes, no. What I on error. Okay. So this is another callback method you can override if something causes an error. then you will get a notification here. Yeah, you configure the monitored item with a node ID, with a queue size. Our sample client is interested only in the latest value, so we have a queue size of 1. We are interested in the value attribute. In theory, you can monitor any attribute, but most of the attributes won't change very often. We configure a monitoring mode, okay, that we want to get a report if something has changed. And by that, we configure a subscription. If it's not yet created, we create one. I'll show you that quite afterwards. Once we have a subscription, this will definitely create a subscription. We add that monitored item to the subscription and connect the monitored item, which means enable the monitored item at server side. And after that connect, you will get information back from the server. Let's come back to the subscription configuration. Oh, thank you. It's again quite easy. If there is already a subscription created, we simply use that one. Otherwise, we create a new subscription and configure it. A subscription has a publishing interval, which means the server sends notifications every 1 second in that time. Okay, I noticed here 500 milliseconds. Okay, let's change it. 500 milliseconds. If there are changes. If there are no changes, then after another 500 milliseconds, there will be a check for changes, and if there are some information will be sent. We have we configure a max keep alive time, max keep alive count, which means if there is no data change detected after that 10 times 500 milliseconds, the server has to send a keep alive signal. And we as well configure set the lifetime count of 60, which means after 60 publishing intervals, and if the server is not able to publish, the server declares the subscription at the server side as dead and deletes it. And obviously we want our subscription to publish, so we enable the publishing and we add that configured subscription to the session, and we connect that subscription, including all monitored items, if there are already some. Did I miss something? No. Yes, here. So by such way, we simply create the monitored items, or one monitored item, one after the other. In theory, it's also possible. Okay, let's show you that again. Here, the toolkit has multiple methods. Here is a method to add one monitored item, but you also can add several monitored items at one time. Okay, stop monitoring is simply implemented as remove the subscription from the session. This will do a disconnect internally and setting the subscription to null means, okay, release the subscription and the destructor will be invoked. Yeah, and finally, after we end, that's the matching while not end. If we decide to shut down the server, we remove the session from the application, and that's it. And that is almost the complete implementation of the tool of a client. I forgot one thing to show you, how you get notified. And this is done in the configure subscription. We we instantiate a sample subscription, a derived subscription from the toolkit, because that subscription has a method which is named onDataChange, which is invoked by the toolkit every time new data changes are notified by the server. And that onDataChange provides you an array and vector of monitored items, as well as a vector of values, and this a vector of data values, sorry. The data value contains timestamps and status codes additionally to the value, to the real value. And I implemented simply in that the sample another printf, where we specify the node ID which was notified, the source timestamp which was notified, and the value which was notified. Yeah. So simply compile the thing. One thing I forgot to show you. It's still time to show that. God. Sorry for that. It comes on the other screen. Okay. Sorry. Okay. You have to configure your project at that place that you configure some. Oh God. There it is. Okay. Yeah. That we have to configure where the header files are stored. In my example, I have installed our toolkit at this place, and we simply provide the paths to that header files to be included, as well for the linker, the additional library paths always comes on different. And this is again at the matching toolkit installation for the desired platform for the Studio 2010 and for the configuration. Debug, or the platform is Win32 and the configuration is debug. And afterwards, I just have compiled it. I can run it. Somewhere it's okay. This is our client. If I like to connect to that pre-configured server URL, I don't get the connection because the server is not yet running. I have to start the server. Just a moment. And in that sample, I'm using the test server provided with the C++ toolkit, simply because I know the address space of that server very, very well. So now the server is running and I can connect to that server. I can read the default value, which is the current time, and get back the current time, where the time is UTC. So it's 13 o'clock, 1 o'clock in the afternoon. But I as well can read other nodes, and I have to specify the node via the namespace. And I know this is a node which does not change its value all the time. So, and I get the results for that node, and I get the value back. Yep. I can write that node, specify the type and the value. Okay. The write result was good, and I read it again and get the written value back. I can monitor. Oh, it's easier to do that. I as well can monitor this node. I get the initial value, and if I write that node again with another value, I get the changed value back. I can monitor another node which changes its value all the time. I just simply know the string node ID of that nodes, and I will get value changes more often of that different node, of that dynamic double. Okay, I can stop the monitoring, that's it. And obviously I can disconnect from the server and exit my application. Everything is done. It's really quite easy to implement such a client with our C++ toolkit to connect to a server, read and write variables, and monitor data changes. Our toolkit provides more functionality, but this is not part of this webinar. It would take a little bit more time to show you how to access historical data, how you, no idea, monitor events or something like that.
Okay, Thomas. So
just one, sorry, just one short thing. I have shown you, oh God, I have shown you the synchronous interfaces of that thing, like read. The toolkit provides both synchronous and asynchronous access. If the server is not responding for a long time, this read will block your application, your thread in your application. So the toolkit provides as well an asynchronous read, which is named session read async, I think, and you will get a response. If the response is detected by the toolkit, you will get a notification by the async read complete method of the session. You have to implement that and you will get the results there. So both, not just read, almost every functionality can be done asynchronously. So you can simply decide what you want to do or whether you want to use a synchronous or asynchronous interface. Yeah, so that's from my side. Thank you.
So we have some questions here. First of all, it is possible to run the client in multi-threading?
The client is running in multi-threading mode. The toolkit is supporting multi-threading in any case, and the toolkit takes care that anything in the toolkit is protected via mutexes or critical sections. So you don't have to care about the toolkit functionality and the toolkit data regarding thread safety. You have just to take care about your data.
Okay, great. So next one is regarding the parsing of the values. I think you mentioned that it's application.
Yeah, it's in general it's your job to do the parsing from some, or to provide a value. The toolkit has a value class that can store, that's more or less a variant, that can store any data type, including arrays or matrices of any data type. And the parsing is simply done here by, let's do it here, by parsing a double into a string into a double, and then provide that double via a method set double to the value class, to the value instance. And there are many functions like set double array or that set float array or set anything. So we provide everything.
Okay. Sorry. Okay, so if there are no questions left, then I would like to say thank you to all you who attended our webinar. And after we finish this webinar, there will be a short survey, and I would be happy if you share all some feedback for us to this webinar. And you see my contact details here on the screen. So if you have anything that you would like to know afterwards, feel free to send me an email or to contact us via our contact details on our website. So thanks a lot and have a great day.
Webinar will be shown as video.
Yes, sorry. So if you would like to, see this again, this webinar, it was recorded, and we will provide this on our website so that you can watch it real live and maybe share it with colleagues or with friends, so that you know everything. And maybe if you would like to test the implementation, then you can also use it. All right. So then that's it from our side. We wish you a great day and hope to hear from you soon. All right. Bye.
Bye.